So am I audible, right?
Yes, sir.
Okay. So this is the week 4. So in this session, our first question will be from the GATE 2021, that is set 2. The question says, an activated sludge process, designed for the secondary treatment. An activated sludge process is designed for a secondary treatment of 7,500 meter cube per day of municipal wastewater. After primary clarifier, the ultimate BOD of the effluent which enters the ASP is 200 milligram per liter. The treated effluent from the secondary clarifier is required to have an ultimate BOD of 20 milligram per liter. Mixed liquid volatile suspended solid concentration in the reactor and the underflow is maintained as 3000 mg per liter, 12,000 mg per liter. The hydraulic retention time and mean cell residence time are 0.2 per day and 0.2 day and 10 days respectively. The respective flow diagram of the ASP is shown below. The underflow volume of sludge wastage is, see they are asking here underflow volume. So they have mentioned here underflow volume. So we will first make the figure. The figure says 7,500 meter of water is going to the aeration tank, then it is going to secondary clarifier. So now look at the for underflow, you have to calculate QW plus QR. So both we have to calculate. Okay. So let's start with the question data. So first I will write. Okay, so mixed liquid volatile suspended solid in the reactor and the underflow is 3000 and 12,000 milligram per liter. So basically, here I can write x x is equals to 3000 milligram per day and xu which is at underflow at 12,000 milligram per day. 12,000 milligram per day. Okay. Now HRT. First we will calculate the HRT. HRT, we know the formula V by Q naught. Okay. So HRT question, in the question they have mentioned the hydraulic retention time and the mean cell residence time is 0.2 day and 10 days. Okay. So basically HRT 0.2 day, 0.2 day is equals to volume of the tank by Q naught. The Q naught flow, total flow they have given 7,500 meter cube per day. So we can write 7,500 meter cube per day. And the HRT is also in day. So basically we get the volume as 1500 meter cube. We get the volume as 1500 meter cube. Okay. Now in the next step, once we got the volume, now we have to calculate the sludge age. Sludge age. So sludge age we have to calculate. So sludge age formula is sludge age theta c is equals to Vx divided by Q naught minus QW Xc plus QW Xu. Uh, it is, you are able to hear, right? Q. So volume we just now calculated 1500 meter cube. MLSS concentration they have mentioned as 3000 meter cube. This is 3000 milligram per liter. Sorry, 3000 milligram per liter. Now Q naught minus QW. So see now sludge age. So sludge age. What is the sludge age? Basically mean cell residence time. MCRT they are given as 10 days. So basically sludge age or MCRT. All these words are basically same. So mean cell residence time, or if you call it as sludge age, both are same. So 10 days. So now you can see Q naught minus QW and the Q at the MLSS concentration the effluent. So MLSS concentration they have not talked in the question. So basically in the treated effluent we will assume there is negligible compared to this inflow, compared to this ASP. So basically here it will come QWXU considering X is near to 0. Okay. From here QW you will get 1500 into 3000 by QW into, so QU they have mentioned as 12,000. So from here we will get the value of QW. If you calculate, you got the value of QW as 7,500. Sorry, just what was the value? So yeah, so QW is equals to 10 divided by 1500. Okay, so it will be, oh, just a bit. Hmm. So QW basically 1500 into 3000 into 10 into 12,000. So you will get QW as 37.5 meter cube per day. So this is you got QW, but they have asked you the underflow. You need to calculate QR as well. So for QW, we do this QR by Q naught is equals to X upon XU minus X. This is XU. From here, if you substitute the value, so QR is equals to X. MLSS concentration we know 7,000. So MLSS X they have given us. So X they have given us 3000. So Q naught is basically ours 7,500 Q naught. This is, so 7,500 into 3,000 divided by 9,000. If you calculate, you will get 2,500 meter cube per day. This is QR. Now for the underflow rate, you have to add both of this. So for underflow is equals to QW plus QR is equals to 2,500 plus uh, QW was 2,537.5 QR. So we got the value of 2537.5 meter cube per day. So is it clear? So since one person again joined, I will just again discuss this question. So basically in this question they are asking, activated sludge process has been designed for the secondary treatment of this much amount of effluent of wastewater. After primary clarified, the ultimate BOD in the effluent which enters into the ASP is 200 milligram per liter. So treated effluent after the secondary classes are required to have an ultimate BOD of 20 milligram. The mixed liquid suspended solid concentration in the reactor and the underflow is maintained as 3000 milligram per liter and 12,000 milligram per liter respectively. The hydraulic retention time and mean retention time also they have mentioned. Now they are asking the underflow volume of the sludge wastage. So for underflow volume of the sludge wastage, so this amount they are asking. So if we look at the figure, the underflow basically comprises of QW plus QR. Now therefore we have to calculate the both QW and QR. For calculating the QW and QR, we have to first calculate the volume of this aeration tank. We calculate the volume using the HRT which is given in the question, that is 0.2 days. Volume we have calculated which came out to be 1500 meter cube. Now from using that volume we calculated the sludge. Now we use the value of sludgeage. Formula of the sludgeage. From the sludgeage we calculated the amount of sludge wasted QW, like this QW we calculated. After calculating the QW, we use this equation QR by Q naught X upon XU minus X. From here, we so here it was 300. So then we calculated QR. So now it is around 2,500 meter cube per day. So if you add both of these, you will get 2535 2537.5 meter cube per day. So which is our underflow value. Is it clear? Is it clear?
Sir,
Yes.
actually, in the official gate and solution, it
Hmm.
was given 37 to 38.
37 to 38 what?
It is the answer given.
Uh, Underflow volume you are talking 37 to 38.
Yeah, in the official site, actually, I had seen that and I had written it on the previous question. It was written
Okay.
37 to 38.
You just check because underflow
Yeah,
volume of
I had solved it as 37.5. That's why I checked it.
37.5 is the QR. See, QW is a 37.5.
Yes, yes, sir.
But underflow when you will talk QW plus QR, right?
Yes,
The
sir.
recycle which is will be going here, then again it will add, right?
Mm-hmm.
So that's why it is, if you calculate only this, then see in the question also they have mentioned that this is the underflow.
Hmm.
Understood?
Yes, sir.
So you are calculating I think QW only here. So that's why you are telling 37.5 meter cube per day. But if you use the logic of the flow mass balance, it will be QW plus QR.
Okay, sir.
Like, did you got see? I have to solve it correctly. I don't know what is the gate answer and all. So, but based on the concept, the way we learn, the if we someone is talking about underflow, it will be QW plus QR.
Yes, sir.
Okay. So, any other doubts? Anything else? Okay, we will proceed to the next question. So, next question says the schematic flow diagram of completely mixed biological reactor with the provision for recycling of solid is shown in the figure. S naught and S are the readily biodegradable soluble BOD. Q, QR, QW is equals to flow rate, meter cube X naught XC. So they have given the denotation what the mean. Now at the end they are asking the mean cell residence time. So mean cell residence time if we have to calculate basically MCRT. So or if you can say sludge age. So both are same. So this we have to calculate. So now for sludge age basically the formula just now we wrote Vx divided by Q naught minus QW XE plus QW XU. Okay. And the question they have mentioned, see here detention time they have mentioned 2 hours. Detention time is 2 hours. So for I look for the detention because we have to calculate the volume here. So for volume is equals to Q into TD. So Q is how much here? 1500 15,000 and TD is 2 hours. So TD is 2 hours. So our volume will be and Q was in per day. Okay, since it is in 2 hours, we have to divide it by 24 for making it per day. So then the value will come out to be 1250 meter cube. So the volume of the tank came out to be 1250 meter cube. Now theta C if we have to calculate. So one more catch, Q in the effluent Z Q XC they have mentioned it at 0. So basically this whole term will become 0. This whole term will become 0 because microorganism the effluent has near to 0 they have mentioned. So theta C will come out to be Vx divided by QWXU. QWXU. So if you calculate, so 1250 volume just now we calculated, then 3000. See, X is 3000 they have mentioned. Now we have the QW. So QW they have mentioned as 50. So your question, see here also QW they are mentioning the one which is getting out. So now is it clear to you?
Yes, sir.
Yeah. So QW is 50 and XU is around 10,000. So you will get sludges as 7.5 days once you solve this. Okay. So this was the question of sludges. So you got 7.5 days. Now if you now again I will explain this. So they have given one flow diagram. In they have mentioned everything regarding the inflow, outflow, and the how the substrate concentration is varying and the MLSS concentration how it is varying. So now they have asked you mean cell residence time. Whenever they will ask about the mean cell residence time, you should know this formula. And so once you know this formula, so then we calculate the volume of the tank. So how we calculated? We use the flow and the detention time which is mentioned in the question. Knowing the volume, we calculated the sludge or mean cell retention time using the data given in the question. So and this we considered as zero because xe. So you can say they have considered it as zero here. So that is the reason we considered there zero. Now, this is one of the practice question. So, a mixed liquid with 2000 milligram per liter of suspended solid has the settled volume of 200 milliliter from a liter of the mixed liquid. Calculate this sludge volume index. Is it safe? So, sludge volume index we have to calculate SBI, and then they are asking whether it is safe or not. So, sludge volume index is equals to VOB by XOV into 1000 milliliter per gram. So this if we know, so VOB basically here is 200 milliliter and X is 2000 milligram per liter. So you have to substitute this 2000 milligram per liter and into 1000. So here you will get it as 10. So you will get around 100 milligram per liter. So the next question, is it safe? Yes, is it? Yes, it is safe. Yes, it is safe. Reason being the value of SBI ranges from 80 to 150 milligram per liter, milliliter per gram. Sorry. Since it is within this range, yes, it is safe. Okay. So yes, it is safe. So this is all about the today's class. So before leaving, I will discuss a few more design parameters and all, so that you will be well acquainted with some words like sludge volume index or HRT, substrate specific growth utilization rate. So for that, I will just write. So basically, because in question they can ask you one or the other way, so you should know that what these parameters mean. So design parameter first is hydraulic retention time or aeration time, then also you can call it as, or detention time. So all these words means the same. So amount of time the liquid remains in the tank, we call it as a hydraulic retention time. So its formula is, it is denoted by theta, like this way we denote it. So we call it as volume of tank ratio of volume of tank divided by rate of flow of tank, rate of flow in the tank. Okay, so V by Q basically. So design first is hydrolysis time. We can call it a radiation time or can detention time. All these things are same. Second thing is volumetric volumetric BOD loading, or you can call it a organic loading rate. So not only these words are important for gate, it is in fact important for any interview which you will be giving. So they can ask what is in the volumetric BOD loading or organic loading rate. So this basically means mass of BOD applied vo- by volume of the per unit mass of BOD applied per unit volume of aeration tank. Hmm. So mass of BOD applied per unit volume of aeration tank. So it's basically you can write Q S naught by V, and its unit is kg per day per meter cube. Okay. So basically Q is the flow rate, S is the influent BOD, and V is the volume of the tank. So this is the second thing. Now third thing is specific substrate utilization rate. We denote it with U. So specific substrate rate is U is equals to Q naught S naught minus, wait, it is better if I uh, here also it is, so basically okay. You just remember Q S naught by Vx. So here basically this means mass of BOD removed per unit mass of biomass in the aeration tank. Okay, so this we also so there is one more thing. So basically it is better if I draw this figure, you will be able to understand. So okay, next slide I will draw. So whatever terms I am mentioning, it will be easy for you to. So this is a aeration tank. So Q naught, S naught, X naught. Okay. So now this is going to secondary sedimentation tank. Okay. So here the is VXS. Here Q naught plus QR. It is Q naught minus QW XES. Here it is QU, which is equivalent to QW plus QR. So one more. I think this figure you will people will be well acquainted. So this is QW XU, and here it is QR XU S. So when I call substrate, so here it is X S. So from this figure you can relate these things. QS naught mass of BOD applied Q S naught basically means CQ and S naught it is going. So mass of BOD applied in the aeration tank. So similar with specific substrate utilization rate, mass of BOD removed per unit mass of biomass in the aeration tank. Now second thing which I want to tell you is about uh, so even in fact this thing. So basically this U can also be expressed as food applied to biomass ratio. U can also be expressed as food applied to biomass ratio F by M. F by M ratio. So in that it is, so basically F by M ratio indicates Q naught S naught upon Vx is equals to food applied upon mass of MLSS. Okay, so 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 lower the F by M ratio, greater is the will be the removal of BOD. Lower the F by M ratio, greater will be the BOD. Now second thing is sludge age. Sludge age. So it indicates sludge age, or you can call it as mean cell residence time. So basically it indicates the residence time of biological solids in the system. It indicates the residence time of biological solids in the system. So or else you can tell it as it can be also it can be defined as average time for which biomass remains in the system. In the system. So here you can say theta c is equals to mass of MLSS, sorry, MLSS in the aeration tank divided by mass of MLSS leaving the system per day. Sorry, MLVSS. It is MLVSS. Mass of MLVSS in the aeration tank, mass of MLVSS leaving the system per day. So here theta c is equals to Vx by Q naught minus QW XC plus QW XU. Till now, is it clear what I am telling? Is it clear? Am I audible?
Yes, sir.
Okay. So this is what we call as theta c, and There is one more term. Anyone has an okay. So there is one. These are the very important terms, which either in the interview or in the gate, somewhere or the other way it can come. So it is very important that you are well acquainted with all these terms. So next thing I will talk about is sludge volume index. Sludge volume index. So sludge volume, it is defined as, so in the next slide if we go, SVI basically. It is defined as it is defined as volume occupied in ml by 1 gram of solid in the mixed liquid after settling for 30 minutes. It is defined as volume occupied in ml by 1 gram of solid after in mixed liquid after settling for 1 minute. So so also it decides degree of, so basically it represents the degree of concentration of the sludge in the system. Degree of concentration of sludge in the system and hence decides the rate of recycling of sludge, rate of recycle of sludge to maintain required to maintain desired MLBSS and food by mass ratio in the irrigation tank. Irrigation tank to achieve required degree of removal. Okay, so always remember SVI remains between 80 to 150 milligram per liter. The range will be 80 to 150 milligram. In some textbook, they will refer 50 to 150 milligram per liter. So it should be between 80 to 150 milliliter per gram. This will ensure there is sufficient settleability of sludge. This will ensure sufficient settleability of sludge. Okay, so these are the important things which you should remember. So for today's class, I will summarize the entire session today once again. So basically, we started with one question. So in that they have mentioned the diagram and they have asked regarding what will be the underflow. So whenever an underflow volume someone is going to ask, you should always do QW plus QR. So uh, also, if in case they are asking about the sludge wastage, so in meter cube per day, then you should calculate QW. So in this question, using the given data, we calculated the hydraulic retention time (HRT). Using the formula of hydraulic retention time, we calculated the volume. After getting the volume, we use the formula of sludge, since sludge or MCRT they have given the question as 10 days. So using that we calculated the value of QW. Then once we calculate the QW, we applied this formula from where we calculated the rate of recycling of sludge, water, wastewater, QR. So QR we calculated, then for the underflow it is QW plus QR. So we got 2500 plus 37.5 is total is 2375.5 meter cube per day. So this is the total underflow. In the next question, we calculated the sludge. Again, they are asking mean cell residence time. Okay, MCRT or sludge both are same. So using the we again use this formula since x is 0. So in the effluent it is 0 MLS concentration. So it the whole unit term will got 0. So the remaining term is Vx by QWXU. For applying this term, we need the volume. For volume, what we did, discharge total inflow into the hydraulic detention tank. So then we got 1250 meter cube. Using that, we calculated the sludge and it came out to be 7.5 days. In the second question, we calculated the sludge volume index, and in that at the end they have mentioned whether it is safe or not. So using the formula VOB by XOV into 1000 milliliter per gram, we got 100 milliliter per gram. Sorry, here it is 100 milliliter per gram. Hmm. So since it is within the range of safe limit, that is 80 to 150, so we can say yes, it is safe. Now coming to the design parameters, we first understood the what is so hydro retention time, aeration time, and detention time all are same. So the retention time is equal to volume of the tank by rate of flow in the tank V by Q. Now volumetric BOD loading or organic loading rate, these both terms are same and it means mass of BOD applied per unit volume of the aeration tank. Now, specific substrate utilization rate U, we denote it with U. So, in this U, it is means mass of BOD removed per unit mass of biomass in the aeration tank, and U can be expressed as food applied to the biomass ratio F by M. So, F by M is equal to food applied by mass of MLBSS. Lower the F by M ratio, greater will be the removal of BOD. Now, then we studied sludge age. Sludge age or mean cell residence time, it indicates the residence time of biological solids in the system. It can be defined as average time for which biomass remains in the system, and it is in terms of formula mass of MLBSS in the system by mass of MLBSS in the leaving the system per day. So to give it in a numerical form, Vx by Q naught minus QWXC plus QWXU. This is theta c. So then we went sludge volume index. Sludge volume index basically defines the volume occupied in ml by 1 gram of solid in the mixed liquid after settling for 30 minutes. It represents the degree of concentration of sludge in the system and hence decides the rate of recycle of sludge required to maintain the desired MLBSS and F by M ratio in the aeration tank to achieve required degree of removal. And it ranges from 80 to 150 milliliter per gram. This will ensure sufficient settability of sludge. So, so this is was all about today's session. So, anyone has anything to ask, you can ask. Else, I request you to please leave the session because this is was the content of today's session.
Okay, sir. Thank you.
Yeah, thank you.
Sir,
Yes,
may I ask what is short circuiting?
short circuiting.
Yes.
See, short circuiting basically means suppose there is a tank. Okay,
Yes, sir.
so in the tank there will be inlet as well as outlet, and there is a water flowing from inlet to outlet. Okay, so, as an ideal case, all the water particles which are entering at the inlet having the same time at the same time should leave the outlet at the same time. Correct. But
Yes,
in
sir.
short circuiting, what happens? A portion of the liquid exits the uh, exit point, like it leaves the tank before the mass of the before the bulk liquid. Do you understand? A portion of the liquid gets out of the tank before the bulk liquid, though they have entered the tank at the same time. Did you understood?
Yes, sir. Yes, sir. Means the volume, total volume doesn't exit. Certain
Huh,
portion stays back.
yes, yes. Certain amount of liquid gets out, though the bulk of the liquid still remains in the tank. Hmm.
Hmm.
So there are many reasons for this to happen. It is there is a temperature difference. It also happens there is inadequate mixing. So and also like there are few reasons. If you can read, you will get to know. Okay, wind circulation is there, so wind is going. Okay, tank is open. So obviously the top surface will be moving quickly compared to the lower surface, right?
Yes, sir.
So
Sir,
all phenomena is there. Yes.
sir, the classes means your class was on Saturday. Last
Yes,
time
yes,
I
yes, yes.
missed it, so
No, no.
I'm not able to get when the classes are being held.
Actually, it is there in the NPTEL site. Okay. Last week
Yes,
I
sir.
didn't took the class on Saturday. So for the last week, this is was the rescheduling.
Okay, sir.
Again
So
tomorrow I will have the class. Yes.
tomorrow you are having the class.
Yes, yes, yes.
Okay, sir. Thank
Yeah.
you.
So any comments regarding the classes and all?
Sir, it's quite good.
Okay. So anyhow, I am going to upload all these videos in the YouTube also. You can go back and you can refer those if you need.
Yes, sir.
Yeah. Okay.
Sir, one more thing. Uh, uh, in wells,
Yes.
lone circular open well, how do we increase the discharge? Means the
Mm.
yield. How do we increase that?
See, that is the water part, right? Water treatment. Here we are dealing with wastewater only.
Okay, sir.
Yes.
Okay, sir.
Yeah.
Fine.
Okay.
Thank you, sir.
Yes. You just read books. These things will be available. So you can get it from anywhere. Okay.
Yes, sir.
Yeah. Thank you.
Thank you.